Chapter 201, Understanding Scale. Understanding scale can be confusing. And I think the reason it gets confusing is simply because we all use CAD these days and we very rarely set up bits of paper to draw our things on. Now, fortunately for me, I can understand scale much easier than new students because I come from the era where I was drawing a lot of stuff on bits of paper. And because of that, I had finite amount of space to play with. So I would usually use the AO size or the A1 size. Okay, so these are the standard sort of page sizes I would be dealing with. And that would give me sort of a real estate area of 841 mil by 1189 mil. The equivalent in inches is there. Now, if you're from the States or use the ANSI system, then the ANSI E, which is equivalent to AO, the ANSI D is equivalent to A1. These are the sorts of sizes that you had on your sheet. So then you would have something to draw, whether it was a building or a housing layout or something, and you would decide what sort of scale you could fit the things on there. Now, often it wouldn't be a problem if there were small domestic projects, then it would fit quite nicely on an A1 at a scale of 1 to 50, for example, or the equivalent would be 1 to 48, which is a quarter of an inch to a foot. So it wasn't necessarily a problem. When you got to a bigger sort of project and you needed to fit more information on, then you might need to either drop the scale down to maybe 1 to 100 or increase the page size. These were the sorts of things that would determine for us what sort of scale we could draw things at. Though notwithstanding that, we also had to think about the amount of detail we needed to show. Now, if we were limited to a scale of 1 to 100, then we couldn't show as much information as we could at 1 to 50 because we were using pens and rulers and stencils and all sorts of other things, and we simply didn't have the dexterity to create all of the detail required maybe at 1 to 100 that we'd be able to show at something like 1 to 50. Okay, so we were limited in that respect. Now, let's go over to the next page and see what will fit on my paper page. And if I had an A1 size, then if I was drawing something at full scale, which I very rarely did because I didn't deal with sort of machine parts or product bits, then the amount of stuff you could fit on there would be 594, 841 on A1. And these are the equivalent sizes for the ANSI D, which is a similar sort of page. So again, as I said, I would think about the right scale for something, and it would usually be a 1 to 50 or 1 to 100 for most buildings, and then that would tell me how much I could actually fit on there if the building was 29 by 42 meters. Now, often they were never that big, so 1 to 50 would be fine. So I understood quite early on all about setting out a drawing and what I could fit on there, and I knew my limitations when it came to drawing stuff. The trouble these days is that on CAD, you can draw anything, any size you like, and at any level of detail. So that poses another question. What level of information do you show at specific scales? Okay, and again, let's think about drawing these things by hand. So next page, 1 to 200. This is a little exercise that I set for students, and it's all about what we can draw really quickly at different scales. Okay, so this was the building that I chose, and it was not far away from where I work. So I took a picture of that and then basically said, in about 5 minutes, draw what you can at a scale of 1 to 200. So at 1 to 200, the building was about 25 meters, and I think it's about 20 meters from top to bottom, from the chimney stack to this very bottom bit. So that would fit nicely onto an A3 sheet. So once we drew that, then the questions were, what sort of level of detail could we show? How much information could we show on this at that sort of scale? So the next bit was to draw it at 1 to 100. Okay, so obviously at 1 to 100, it's now twice as wide and twice as high. So you can't fit the same stuff onto the same piece of paper. But what you can do is show it at a higher level of detail. Okay, more information about the windows and the doors, more information on the chimney stacks, more information on the timber, etc. And if we move through the scales, you can see now this red box is getting smaller and smaller, honing in on certain things. So we can draw much less at a 1 to 20 scale, but we can show a huge amount more information. Okay, and it kind of takes the same amount of time or maybe longer at this sort of level because we're focusing in on the detail. As opposed to drawing all of it in a sort of general sense, we can now really focus in on certain bits. And the final bit was at full scale, we could draw the door number and the door knocker. It got the students to think about what sort of level of information you can show at certain scales, and then whether it was appropriate to the output that you required. Now, often 1 to 50 or 1 to 100 would be sufficient. This level of detail might be fine. Okay, 1 to 200 might be fine as well. Depends what you need to show. But if someone wanted to know all about that door knocker, then 1 to 200 scale is not going to cut it. It needs to be something like this. Okay, so hopefully that's explained a little bit about scale. It all does depend on output size. So if you know how big your piece of paper is that you're finally going to print it or plot it to, then you stand half a chance of getting it right.